Hello, ladies and gentlemen. I hope everyone is doing well today. Today we are taking a look at another chemquest, this time on quantum numbers. So remember, guys, quantum numbers, they come from quantum mechanics, and they're used to describe the location of an electron. So one thing is the Heisenberg uncertainty principle. So this states that it's impossible to know both the exact position and the exact velocity of a small particle at the same time. Because of this, when we're identifying the location of an electron, it's based on probability. So it's the most likely spot that you're going to find an electron. And yes, guys, it is worth noting that Heisenberg, so this is the scientist that inspired Walter White's alter ego from Breaking Bad. And if you think about it, it makes sense. Because Walter, he's viewed as the uncertainty principle. As he gains momentum as a drug lord throughout the series, he loses sight of his original position as a family man, as a chemistry teacher. So the exact moment when Walter becomes evil is what we could call uncertain. Little things like this is why I love Breaking Bad. But we can move on. So quantum numbers. These are used to describe the most probable location of an electron. In Table 1, you'll find the 4 different quantum numbers that you need to know and what the quantum number tells us. So it is worth noting that throughout this video you will hear me say M sub L, M sub S. That means M subscript L, M subscript S. So when you hear me saying these M sub L, I'm referring to the magnetic quantum number, M sub S, I'm referring to the spin quantum number. It is also worth noting that the order of the quantum numbers is important. If you look, I have it boxed in right in here. The order goes N, L, M sub L, M sub S. This describes the most probable location, just like how X, Y, and Z can describe the location points on a graph. You know that X comes first, Y comes second, and then Z comes third. Same thing with quantum numbers. It goes N, L, M sub L, M sub S. In table 2, you will find the rules governing what the values of the quantum numbers are allowed to have. So you will see here the first quantum number, n. N can be any integer. It can be any 1, 2, 3, 4, or higher. L it can be integers up to n minus 1. So to calculate L, they can be any integer equal to n minus 1. M sub L is equal to negative L to 0 to positive L. And then lastly, M sub S. M sub S tells us about the spin of the electron. Positive 1/2 means an upward arrow, negative 1/2 means a downward arrow. In these examples, you can find several examples of what I just said. Right here, so the first critical thinking question, question 1. So we're going to use table 2 to analyze each quantum number. When we're analyzing each quantum number, we can use the rules to make sure that they follow all the rules to determine if these are possible values. So I will squeeze table 2 in right on the top, and then we can do 1A together. So we analyze each individual quantum number to make sure that they make sense. So we look at n. N can be any integer. Is n an integer? Yes. So we know that n is correct. Next, we can look at L. It tells us L is equal to n minus 1. We see here that n is 4. L is 4, because remember it goes n, L, M sub L, M sub S. L cannot equal 4 in this case, because L must equal n minus 1. So again, go through, look at, for 1A, B, and C, look at each of the different rules that govern the quantum numbers and see if they make sense. Question 2, 3, and 4, or 2 and 3. 2 and 3 are the same kind of thing as 1. So now, instead of figuring out what's wrong, it's just asking you to calculate a few of the quantum numbers. Use the possible values to help you answer questions 2 and 3. Next, question 4. So question 4 is filling in this blank. A few things that will be helpful when you're filling in this blank. So use the energy level. Remember, N equals the energy level, so that's what the first column is also asking us. And then remember, L equals N minus 1. So when you're calculating the possible values for L, use that formula, N minus 1. Remember, N is equal to the energy level. When you are figuring out the sublevels, remember you can use table 1 from an electron's address to help you. This is the previous chemquest. And then number 5. So number 5, you are going to have to use table that you fill in number 4 to answer the questions. Look at the trend. Use the trends that you see in this table to answer question 5. So next we have another table. As you can tell, guys, just different tables to help us see different relationships. So this table, we're relating the azimuthal quantum number L with the sublevel, the number of orbitals, and now the possible m sub L values. So we're going to use this table and the next few questions to figure out what those m sub L values tell us. So watch, I'll help you guys with 6 and 7. Then you can answer 8 and 9 similar to how I answer 6 and 7. Again, I just have the table on the top, so then we can use it to help us. So how many m sub L values are there for a D sublevel? So we would look here where it says D, and then we would count them up. 1, 2, 3, 4, 5. 5. Next, how many orbitals are there in a D sublevel? So we'll look at orbitals, we'll look at D, and then we'll see it's 5 again. Now 8 and 9 do the same thing for F, and then in question 10, what do you notice? What do you notice about the numbers of all the m sub L values and the number of orbitals? You should see something similar between them. Next, we are going to be correlating the quantum numbers to what we already know. Remember, guys, these are called orbital diagrams. Just this time, now we are labeling the parts of the orbital diagram with quantum numbers this time. So remember, guys, N equals the energy level. So that's what we see right here with the 3. N is the energy level. Then we have L equals the sublevel, which we see right there, pointing to P. Then we have m sub L. This is the orbitals. So remember, guys, the orbitals are 1, 2, 3. They're the lines. And then lastly, we have m sub S. M sub S tells us the spin of the electron. Remember, plus 1/2 equals an upwards arrow. Minus 1/2 equals a downward arrow. It is worth noting, guys, when we label our m sub L values, we must label them correctly. So we can label the m sub L values here in the 3p orbital. We can use this list of m sub L values to help us. So we look at P. Look, you have 3 lines, you have 3 m sub L values. They go in the same order from low to high. So your first one would be -1, the second one is 0, and then the last one is +1. That is how you are able to label these. Then lastly, guys, questions 11 and 12. Use the quantum numbers where they relate to in the orbital diagrams to answer questions 11 and 12. Like always, guys, if you have any questions, please remember to circle them, write down your question, and remember to ask me in class. Like always, I will try to end these with a joke. What do you call a cow with no legs? Ground beef. Get it? Because he'd be laying on the ground, no legs to stand on. Hope everyone has a great day. I will see you next class.